What's good, everyone? Going to continue on with the SageMaker Inference video series. And another topic or new topic that we're going to bring up that we will be accessing through the large model inference container is sticky session routing. And what we'll do in today's session, right, is quickly theoretically kind of overview what is sticky session routing. It's not a new concept to just generative AI specifically, even though we'll apply it in that domain today. We'll talk about some of the pros and cons, when you should use it, when you shouldn't, maybe when you should consider kind of some other alternatives. And as always, we'll talk about how we can enable it through our tool of choice today, which is SageMaker, and then that large model inference container, which once again helps us deploy kind of LLMs in a very optimized manner through different backends like VLM, TRTLM. And we'll get hands-on with the notebook. Today will be a bit of a shorter video, but you can take from this one more method or one more way of kind of optimizing for latency and then also building stateful applications. So with sticky session routing, right, the idea here, like I said, this is a traditional kind of software concept that you can also apply to generative AI. When we have multiple nodes or instances, right, behind our endpoint, and we have specific sessions, especially, and the analogy you can think of here, right, is maybe you're on ChatGPT and you're having a chat, like at the moment, and then you've set some information within that session. You want that information to be easily retainable for your model, right? And kind of basically make sure that that information is already existing on whatever node or wherever else that session is being conducted, right? So for sessions, rather than having to have different node to node kind of based communication, any information in that particular session ID, everything as long as that session is open should be routed to the same instance. And here, right, this helps us build more stateful applications because we retain kind of that information that has already happened within that session already. And we also have it all accessible within that same instance and same node. So you can see how this improves our latency, right? Especially when we don't have to deal with kind of internode communication or data transfer and data sharing. When we have everything on the same instance for that particular session, that makes it both stateful and optimized for latency, because we're avoiding that cost of having internode communication, basically. So the positive there is that statefulness that we establish, and then that latency optimization there is especially handy, obviously, in kind of chatbot-based applications and different use cases such as that. And it's very common, right, in these different GenAI applications that we see. Another example, right, is if we kind of paste like an image or something in the chat, we don't want to have to send that image again every time if we're asking questions about it. We want it to be stateful, basically, and retain that information. So that, at a high level, is what sticky session routing is, and those are some of the benefits. Now, there are some cons or considerations that you also want to think of. Inherently, right, let's say that instance or server goes down. This makes it a little difficult for your application to be highly available, which is kind of one of the best practices when it comes to especially architecting on the cloud or just building kind of scalable systems, right? So if that server goes down and that's where the information is, then how for that session do you retain that information, right? And it's in cases like this that you want to kind of consider things such as central data stores, and this can be something like a database even. And obviously with this, there is a bit of a maybe latency cost that you have to think about in terms of the considerations that are happening here. But once again, this will then be more available in the case that that server or particular instance with that information does go down, right? So there are some cons in the sense that it kind of it's a bit of an anti-practice across the highly available or like kind of centralized type of data store that you would want across all your instances just in the case of any failures. So that's a consideration to have there. And naturally, some applications also are stateless. So in the case that your application has that, this feature is not really like something that's going to bring too much value. So the main key here is you want to really think of when this makes sense and for what use cases it makes sense. Kind of like I said in a chatbot-based setting where a user logs in and they have a session that's persisting for them while they're on that app. It makes sense there. You want as latency optimized of an experience there and a stateful experience, right? So in cases like that, you want to enable sticky session routing, but like I said, this is not just something that works across every single use case. You really want to take a look at the trade-offs and the pros and cons of when to use it. So now that we have an idea of that, right, the third thing is, how can we enable this through SageMaker and LMI, the large model inference container? It's pretty simple, right? Through VLM, basically you can enable, once again, in your serving file, that you're enabling sticky sessions as true. And you can also enable or configure how long this sticky session should be existing basically as well. I think the default is 30 minutes. I need to check that. I'll link the documentation. You might want to double check that value there. You can enable that there, right? And then when you invoke our SageMaker endpoint, you can basically specify a header known as session ID. And this is our unique identifier for that session that we were dealing with. I'm butchering the spelling here basically, but you get the idea there. And you can basically open and close these sessions with special headers upon that invocation request, basically. So you have that control as well through that same invoke endpoint call. If you've seen the SageMaker series so far, you know that invoke endpoint call is how we talk to our hosted LLM. So through these headers, we kind of get an understanding of that. There's not much code change from what we've already seen. There's just going to be these few kind of nits that you have to pick up on and that you can enable in your serving file and then kind of pick up on these session IDs as well. So with that being said, we'll get right into the notebook. Like I said, if you want some more background in terms of LMI Container, I'll link that down below in the description as well. But that will give you some context in terms of how we're actually hosting this. I recommend you take a look at that if you're new to this. We're in our usual setting, SageMaker AI console. I have a classic notebook instance opened up right here. And in our Git repo that we've been working with this whole video series, which I'll link down below, we have a sticky session routing notebook right here. And just for some context or background too, right? This was actually initially launched with the TorchServe container, I think about a year back for SageMaker. But now that I think AWS in general or SageMaker in general is standardizing a lot more on this large model inference container, especially for LLM deployments, there's support here as well. You can find the official docs here. I borrowed most of the code from there and just applied it for my own LLM that I chose. But you can use this to also kind of understand more about the implementation. I recommend just kind of taking a look at that to understand what you can configure. And the one other call out, I should probably add this to the notebook as well, is there's only support for this through SageMaker endpoints at the moment, not inference components. So keep that in mind, but that also might be something that is variable to change. So just keep an eye on that. But here, that's why we don't create an inference component. We directly create a classic SageMaker endpoint. We're going to have the same tools we use here, our SageMaker Python SDK, and you can use Bodo 3 once again, the lower level SDK as well if you'd like to use that. I set up my clients here that I'm going to work with, and then I'm going to use the latest and greatest container, which is V16, and I'm going to be using the VLM async mode here. We'll use another Qwen 3 model here. Lately, I've just been working with that simply from Hugging Face. You only need a single GPU to hold this, to host this one. And then if you notice, right, I'm going to specify one option here, this session's expiration in terms of the duration for the session to exist. So if you don't close it, this is the amount of seconds it will be valid before it expires, basically. The default's 1200 there, as I think that's directly from the docs itself. But I set that flag there. And by default, I think sticky session routing is enabled. You can check that too. That's a parameter there if you want to make it true or false as well. Then these are just the traditional SageMaker constructs. Our model object will point towards our serving configuration here, which will pull down the model data into the instance memory. We have our inference image, which is LMI v16. And then we're also going to create our endpoint config. And here I have two instances, and I'm going to be using, I believe, a G54X large here. I've specified that any production variants you have, anything you want to work with. You also want to tune these parameters in case you are pulling down a larger model, and that startup might take a little longer. I then create my endpoint here. This will take anywhere between 5 to 7 minutes. This varies depending on your model size in terms of the resources that are being pulled down. But once I have this, I have my persistent SageMaker endpoint that I can be working with. Once again, no inference components that we'll be dealing with, just our different variants that we might set up there. So if you have any A/B testing or anything of that sort that you want to do, you can also enable that. Now, what's a little different here is, right, our special requests that we're going to send to start and close it is what we have to specify to kind of parse and create our session ID that we can work with. So if we see here, I'm going to pass in a special payload, and for the request type, I'm going to say new session. And our serving backend will automatically pick up on that and realize, all right, in this response, I've created a new session. So you can grab the header specifically for that, for this new session ID. And this has been created for us by default, basically. So that's all we're doing. We're going to parse this with that special payload that we passed into the invoke endpoint call. And we're going to grab this session ID. We now have a new session that we can work with. Then I pass in what is Amazon SageMaker, just a sample payload. Don't worry about the response. You can tune it as you need. But the special header that we're going to be passing in, we normally don't only have these three, right? traditionally that we need to work with this, or an inference component header, is our session ID that we're working with. So now we know that we're in this session. I'm going to pass in that ID that I've parsed from that special payload that I sent in to start a new one, and then we're going to get a response here. Now, once that's done, right, you can imagine, let's say maybe in your chatbot, the user's logging off. You realize, okay, this session has ended. That's a termination right there. Let's close this session. And very simply for that as well, you have a request type saying close right here. This is a special payload once again for closing the session. And we pass in the session ID that we parsed for once again there. And then when you grab the closed session ID, you should see that this mimics basically the one that an instantiator started there. So if these are the same, you know that you properly started and closed one. And now if you try to use that same session ID, right, it's not going to work anymore. So if I pass in the session ID, you should see an error with this last cell here where it's saying, okay, this is an invalid session ID now because we actually closed that right there. So you're going to have to start a new one with that special payload again. But yeah, at a high level, that was mainly what I wanted to introduce. I know this was a shorter video, but it is a feature that is sometimes needed in specific applications, and especially for GenAI, for stateful and personalized applications, right? Like chatbots, where you have sections for specific users. This becomes a very, very valuable feature that you could be using. But like I said, keep in mind the pros and cons as well in terms of when to use it and when not to use it. There are certain optimizations that apply across all use cases. I wouldn't say this is one of those. It depends on when it's handy to use, depending on your application. So kind of always think backwards from your problem and what you're trying to solve for and see if this makes sense. And it's just one of many different things you can look at when it comes to optimizing latency and things of that sort, especially for stateful applications. But thank you for watching as always. If you have any questions, feel free to leave them down below. Any doubts, reach out to me in whichever way comfortable, LinkedIn, Twitter, wherever it is. If you enjoyed the video, feel free to leave a like and subscribe. There's many, many more things in this LLM hosting space that I'll be talking about, and those optimizations especially that we can talk about in terms of improving LLM hosting performance. That's a field that we really want to tackle, so I'll be back with much, much more there. Thank you as always for watching, and have a good day, everyone.